Morning everybody. In yesterday's class we were discuss about the preparation methods and properties of interhalogen compounds. In this class learn the structure of interhalogen compounds. We know the interhalogen compounds, that is X dash having the same ratio, second X-3, X-5 and X-7. So depending upon that structure of interhalogen compounds, first ICl, name of that compound is iodine chloride, iodine monochloride, that containing only one chloride. So iodine monochloride having the structure, in that compound iodine is a central atom, that is larger or bigger parent, and chlorines, two chlorine atoms can be attached to the central iodine. So structure is formed what? Iodine can linked with two chlorines to form the straight line structure. Straight structure is called as linear structure. It's called as linear structure having 180 degree angles. 180 degree. Cl, chlorine, iodine, chlorine can possess the straight line structure, that is called as shape, linear shape. Second one is the ClF, 1 chlorine, 3 fluorine. Name of that compound is chlorine trifluoride. Chlorine trifluoride having the structure, the chlorine is placed at the center and that central halogen can linked with 3 fluorine atoms. 3 fluorine atoms to form the tripod like structure, that having the angle 89 degree. 89 degree in that FClF, fluorine, chlorine and fluorine can possess the 89 degree angle. That shape is the bent T-shaped structure. Actually that is T. So likewise that T-shaped structure, bent T-shaped structure. So these are the two, iodine monochloride and second one is the chlorine trifluoride. Next BrF3, bromine trifluoride, like to the chlorine trifluoride, having also the bromine is central atom and 3 fluorines can attach with each other to form the bent T-like T-shaped structure, in which this bromine possesses this lone pair of electron. This bromine can possess the lone pair of electron. So these are the 3 structures of interhalogen compounds. After that, see the next structure, BrF5. BrF5, name of that compound is bromine pentafluoride. BrF5, bromine pentafluoride, 1 bromine and 5 fluorine atoms, in which the central bromine atom can linked with 5 fluorine. Central bromine can linked with 5 fluorine to form the structure. That structure is likewise that, and shape is the square bipyramidal. Square bipyramidal shape is obtained. Then last one is the ClF5, chlorine pentafluoride. Chlorine pentafluoride. This compound containing only 1 chlorine and 5 fluorides. So name of that compound is chlorine pentafluoride, in which the structure is the central atom chlorine. Central atom chlorine can linked with, central atom chlorine can linked with 5 fluorine atoms. Likewise that 5 fluorine atoms to form the square pyramidal structure which can possess also one lone pair of electron and having this shape square pyramidal. So all these interhalogen compounds can show the structures likewise that. First is the linear, you can see that linear. Second one is the bent T-shaped, third also bent T-shaped. Next is the square pyramidal, and last one is also can possess the square pyramidal. So all these structures can shown by the interhalogen compounds. Then see the last point of interhalogen compounds, the uses of interhalogen compounds. Uses of interhalogens. Uses of interhalogens. These interhalogens compounds can behave the uses differently. That may be first XX dash and XX dash. First XX dash and XX dash 3. So uses of XX dash, that may be chlorine fluoride, bromine iodides, anything. So first of all, XX dash compounds are used to determine iodine value of oils. It is used to determine iodine value in oils. What? Those compounds containing oil can be determined from that iodines. So iodine is determined from oils. Iodine is determined from the oils. That is first. Second one, it is used as catalyst. It is used as catalyst in chemical reactions. It is used as catalyst of arsenic third, the element of p block element arsenic. So XX dash interhalogen compounds are used as catalyst of arsenic third, AS third. It is used in preparation of polyhalides. It is used in preparations of polyhalides. What? Those compounds containing halogens more than 2 called as polyhalides, and that polyhalides compounds can be prepared by using the XX dash interhalogens. So these are the 3 uses of XX dash. First, it is used to determine iodine value from oils. Second, it is used as catalyst for the arsenic. Third, next it is used in preparation of polyhalides. After that, see the uses of XX-3. Uses of XX-3. First use, it is used in preparation of polyhalides. XX-3 is also used to prepare the polyhalides like to the XX dash. So first use of XX-3 is used to prepare polyhalides compounds. Polyhalides compounds can be prepared by using the XX-3. Then it is used as fluorinating agent. all the compounds of XX-3 like to the ClF3, BrF3 can be used as fluorinating agents in chemical reactions. Those reactions can require the fluorinating agent. At that times XX-3 compounds are used. Then the XX-3 interhalogen compounds are used as non-aqueous solvents. Non-aqueous solvents. See again, XX-3 compounds are used as non-aqueous solvents. Means what? Those compounds cannot be dissolved in water, that can be dissolved in XX-3. Therefore, it is called as non-aqueous solvent. Then it is also used for the fluorinating agents. All these are the uses of interhalogen compound. Here, the halogens, that is G17 elements, can be completed. Then see the last group of these elements, that is the G18 elements of the P block. Group 18 elements. G18 elements. First of all, see the definition of G18 elements. What is G18 elements? The elements that is helium, neon, argon, krypton, xenon and radon. See again, the elements: helium having atomic number 2, then neon atomic number 10, argon having atomic number 18, next krypton having atomic number 36, xenon having atomic number 54 and radon having atomic number 86 are placed in group of periodic table. Group of periodic table is called as G18 elements. So this is a simple definition of G18 elements. What? The elements: helium, neon, argon, krypton, xenon and radon are placed in a group of periodic table called as group 18 elements. It is also called as noble gases. It is also called as noble gases or zero group elements. These elements, G18 elements, are also called as noble gases or zero group elements. So these elements can occur in periodic table in the last group of periodic table. So these are the group 18 elements. After that, see the electronic configuration of G18 elements. Next, electronic configuration of G18 elements. We know in previous class, understand the electronic configuration of G16 and 17, which is the general electronic configuration of G16, that is NS2NP4 of the G16, G17 NS2NP5. So depending upon that, the general electronic configurations of noble gases, the general electronic configuration of G18 is NS2NP6. one electron in P can be added. 16 containing P4, 17 containing 5 and 18 containing 6. So the general electronic configuration of Z18 elements is NS2 NP6. This indicates the last cell of all these elements containing 8 electrons, 2 plus 6. How much? 8 electrons that can be completed their octets. Hence, all these elements can get the stability, cannot be participate in chemical reactions. Therefore, all these elements are called as zero group elements or inert gases. Zero group elements or inert gases due to their not participation in chemical reactions. So after the general electronic configuration, the condensed electronic configuration of Z18, condensed electronic configuration of noble gases is as follows. See the condensed electronic configuration of zero group elements. For that purpose, first of all, see the serial number, then elements, name of that elements, then symbol, then atomic number of that element, and last, that is condensed electronic configuration. Condensed electronic configuration. First of all, take the all 6 elements which are placed in G18s. That is first helium having symbol He, atomic number 2 is the first element, helium. After that, second one is the neon having symbol Ne and atomic number 10. Helium, neon. Third, argon having symbol Ar and atomic number 18 is the third element. Helium, neon, argon. After that, krypton. Krypton symbol is Kr and 836. After that, xenon. Xenon having symbol Xe and atomic number 54. And last is the radon. Sixth element is the radon having symbol Rn and 86 is the atomic number. Then see the condensed electronic configuration of noble gases. So first noble gas, that is helium, having here 1s2 is very simple. 1s2 is the general electronic configuration of that helium. After that, neon can possess 1s2, that is 2s2 2p6. Neon containing 10 electrons can distribute 2 electrons in first cell, that is 1s2, and second cell containing 2 plus 6, that is 8 electrons. Second cell containing 8 electron, 2 electron goes to the S subcell and 6 electron goes to the P subcell. But actually this 1s2 is the electronic configuration of zero group element helium. So the condensed electronic configuration is taken as helium 1s2 2s2 of the neon. Then for argons we have to take the next zero group element after the helium, that is neon. For krypton can take the argon. For xenon can take the krypton, and last for the xenon. For taking the condensed electronic configuration of first neon, can take the helium, that is 2 electrons can goes, and remaining 2s2 2p6. Then for argon 18, neon is taken as the nearest zero group element, that containing 10, remaining 8 electron goes to the 3s2 3p6. 3s2 3p6. Then for krypton, containing 36 electrons, out of that 18 can goes to the argon, argon having the atomic number 18, and the remaining electron can goes to the 3d10 4s2 4p6. See again, these 18 electrons plus 2, that is 20, plus 10 30, plus this 6 36. After that, xenon having the atomic number 54, but we have to take the nearest zero group element, that is krypton, having the atomic number 36. After that, remaining electron goes to the 4d10 5s2 5p6. Can calculate this 36 plus 10, that is 46, plus 2 48 plus 6, that is 54. And last one is the 4f5 4f14, then 5d10 6s2 and 6p6. See again, last element of G18, that is radon, having atomic number 86. Out of that, the 54 electron goes to the xenon, that is 54 plus 14 in F, D containing 10 and S containing 2, and remaining 6 electron goes to the P. So this is the electronic configuration of noble gases